All right, so we did horizontal shifts, so now let's do vertical shifts. So again, we're going to start with our base function, log base b of x. Now for any constant d, the function is going to be log base b of x plus d. Now, if d is positive, we're going to shift up d units. If d is negative, we're going to go down d units. So this one's probably the easiest one. All we have to do is move up or down. Now our vertical asymptote doesn't change because all we're doing is moving up and down, so that doesn't change. Now our domain, because that is still x equals 0, it doesn't change. And the range, of course, doesn't change either. Okay. So this is what our top function is. This is our original function. And all we did was we added 3. So if we look here, our original function, well, that was our 1, 0. And then we had 2, 1. So 1, 2, 1. Those are our original points. And then we added 3 to the output. So 1, 2, 3. This is 1. And so we have 1, 2, 3. And then we could draw our graph. Now we could also do the same thing. We could subtract, 3. And what we'd have is our original point here, 1, 0. And our other original point here, 2, 1. And if we subtract 3, we get 1, 2, 3. That's our new point. And we subtract 3, 1, 2, 3. And that's our new point. And then we could draw our graph from there. Okay, so all we're doing is moving up and down. And so we just change our value of our y. X's stay the same. The y's are what changes this time. So let's do a graph of it. And this one, again, alongside the parent function. So what is our parent function? Let's do that first. Well, it's y equals log base 3 of x. So we have the 0.10 and we have the 0.31. Okay, so that's what we have. And what do we know? Well, our asymptote, let's go ahead and make it red maybe. So that's going to be x equals 0 is our asymptote. And does that change for either one of them? No, it's going to be the same asymptote for both our base function as well as our new function. So we'll leave that like that. Now let's draw some lines in here. So we know that 1, 0 is our 1, and then 1, 2, 3, 1. So that would be our parent function. Okay, that's the base function we have. Now, what are we going to do? Well, we're going to move up 2. So if we move up 2, that means y is going to go higher. So if we think about this, if we have log base 3 of x plus 2, we're just adding 2 here. So that becomes 1, 2. This becomes 3, 3. And so that's all we've done. We've added 2 to our y. So we could do it here too. 1, 2. And here we could do 1, 2. And that then would be our new function. Okay. Now what happens to the domain and our range of our new function? Well, the domain is still 0 to infinity, and our range is still from negative infinity to positive infinity. Okay. It just has moved up. That's all we've done. Okay, and so those are our key points. And again, we could have got the key points and plotted those only and got our graph, but we could also go from the graph and add up to that way. Okay, all right. What about vertical stretches and compressions? Okay, well, again, we're going to start with our parent function, log base b of x. And so for any constant a greater than 0, then we're going to have a log base b of x. Now, if a is greater than 1, then we're going to have this stretch is going to be multiplied by whatever that is. And so it's going to be stretching it. So we're going to move it up. Okay, so we're going to take 3 times whatever it is or 4 times whatever it is. We're taking a product here. Now, if a is between 0 and 1, that's going to end up being a fraction. It's going to be, a is going to be 1/2 or 1/4. And so we're going to compress it down is what we're going to do. Okay, and again, we've seen these things before, except now we're working with log functions instead of just, an x or something like that. So does our vertical asymptote change? No, it's still going to be x is equal to 0. Now our x-intercept, well, it's still going to be the same. And no matter what we do to that one, it's going to be still part of the new function because that's going to be, we're taking this times basically our output. And so we're not changing that. Our domain stays the same. Our range stays the same. So let's look at this. So our original function is log base 4 of x. And so that's kind of an x there. Kind of make it look a little better maybe. And so, we have our point 1, 0, no problem. And then we're going to have 1, 2, 3, 4, 1, and that's our other point. Now, when we have a is 3, we're multiplying this times 3, okay? So for y. So 1, 0, if we think about that, 1, 0, if we multiply 3 times y, well, we get 1, 0. Now this one we had what? We had 4, 1. Now, if we take 3 times y, we get 4, 3. So does that give us 4, 3? 1, 2, 3, 4. 1, 2, 3. Yep, that's our new point. And so then we have this function for when we have a greater than 1 and it's equal to 3 in this case. That's a vertical stretch. Now, compression, what's going to happen is we're going to have, something between 0 and 1. And so in this case, we used 1/3. And so in a similar manner, we're going to have the same kind of thing. So now we're going to take 1/3 y. And so again, 1 times, or 1, 0, when we take that, we still get 1, 0. But for 1, well, all of a sudden now we have 4, 1/3. And so our 1, 0 is the same, but now we have 1, 2, 3, 4, and now it's up a third. And so that's our new point. And so what happens is it compresses it the steeper here, and then it goes out further like that, and it's much lower. Whereas this one, it went up more gradually, and it's just kind of going like that. So it stretches everything up, and this is compressing it all down and making it a compression. Okay. And again, depends on if your A is greater than 1, or in this case, it's going to be between 0 and 1. All right. So what is our basically our parent function here, and what is the new function? Well, our parent function is y equals 1/2, not 1/2. That's not what I'm thinking here. I'm writing the function again. Is log base 2 of x, okay? And so we have the point 1, 0, and now we have the point b1. Well, b is 2, comma 1. Now what we're going to do is we have the function 1/2 log 2 of x. And so what are we doing? We're taking 1/2 times our y. Well, that's 1, 0 still, but this now becomes 2, 1/2, okay? Now, what do we know about these two functions? Well, they're still going to have x equals 0 for the asymptote. We're going to have 0 to infinity for the domain. And our range is going to be from negative infinity to positive infinity. So now what we can do is we can draw that. So we'll have, we'll just put it kind of here. That's our x equals 0 for our asymptote. And now we have 1, 2, 3. Maybe we better put that. And then we have 1, 2, 3. So 1, 0, and 2, 1. 1, 0, and 1, 2, 1. So we have something like that. And then we have 1, 0 again, but we have 2, 1/2. So 2, 1/2. And so what's happening here, it's going to go up steeper, and then it's going to come across like that. So steeper in this first area here, closer to that asymptote, then it comes through, and then it goes out, and it's a lot flatter than our original parent function, okay? And so that's compressing it down towards that x-axis. All right, so now we have kind of a combination. We have, we have the new asymptote, we have moved up or down, and in this case, we've stretched it, okay? So what we're supposed to do is state the domain, range, and asymptote. Doesn't say draw your parent function. So what I'm going to do is let's start with what is our parent function? Well, the parent function is log of x. Okay. Now log x, what does that mean? Well, that remember is just a 10. When it has just log, it's considered a 10. So what I want to do is I want to have all these different transformations figured into my points. So let's start with this one. What is my point? 1, 0, and since this is a 10, it's going to be 10, comma 1. So that's kind of the start or the parent function. Then what I'm going to do? Well, let's do this piece here next. So what does that tell me? Well, that's going to be moving to the right 2. So let's call this right 2. Well, what does that do? That's going to affect my x's. So 1 plus 2 is going to be 3, comma 0. And 10 plus 2 is going to be 12, comma 1. So that has given me this piece. Now, what do I want to do? Well, now I want to take and I'm going to multiply my y times 3. So this affected my x, the input. This is affecting my output. So now I'm going to take 3 times y. Well, 3 times y here is still going to be 3, 0. 3 times y here is 12, comma 3. So that would be the new point here. Now what I'm going to do is I'm going to say, well, I'm affecting y again, but I'm going to move up 1. So I'm going to go up 1. And so when I do that, that adds 1 here. So that's going to be 3, 1. And here that's going to be 12. 3 plus 1 is 4. Okay. So this then is my final 2 points, my key points. You know, this started as my B1 and this one started as the 1, 0. But now I have that. So what do I have now? Well, my asymptote is going to be at what? It's going to be at x equals 2. So not equal, but that's okay. 1, 2. All right, so we're going to have the asymptote at x equals 2. Okay. Now I have 3, 1. So 3, 1 is that point. Then I have 12, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, and then up 4. So somewhere in that vicinity. And so it's going to have a shape that looks something like that. Now, what is my domain? Well, now my domain is based on that asymptote, so it's going to be a 2 comma infinity. And my range, well, guess what? It doesn't change. It's still negative infinity to positive infinity. So I've got my domain, my range, I've got my asymptote, and I've drawn the graph of it. And again, I started with my beginning points, my 1, 0 and my b comma 1, and then I just did the transformations on those 2 points alone until I got that point, and then I drew a smooth curve between them, okay? And so that's how I would go about solving these. Start with your 2 initial points for your base or parent function, and then do your transformations along the way. All right, so let's pause there and we'll come back for more.